The only hard thing in Rust is async. That's a like highly controversial view. Question here is, what is async and await, and why is it harder? This is going to be tricky to explain in 2 minutes, but I'll see if I can do it.
Hey team, it's Tim from the future here, and I was not able to do that in 2 minutes. But here's what I did get done and why I thought it would be really useful to upload the recording. I explain why asynchronous code exists at all. I then talk about what it means for computation to happen in the future, what Rust's future trait is, what the async and await keywords are, and why they are in your source code. I then talk about what an executor is, and then wrap up by unpacking the Tokio main procedural macro. Along the way, you'll find me debugging a bunch of code like borrow checker mistakes, and that's because I was doing this live on a live stream. If you'd like to see future videos or future live streams, please follow, subscribe, like, all of the good things.
Let's think of something to process. Let's say that I am a task and I have an outcome. I'm using the word outcome because I don't want to use the word result. Once the task is complete, we will have an integer. When it is initialized, we don't. But let's say that we have a function here, work. Work produces a task. And it's going to return a Boolean once it's finished. So sometimes I might call work, but not be done. So the outcome starts as none. And then item outcome equals sum 42. We've got our task T. We initialize one. Yes, I could have used methods. Let's do that. Let's say that work is an async function, which returns a Boolean, but it also modifies some internal state in the struct. And now that we've got a random number generator, why not just produce an i32? We're going to say between 0 and 100. Inclusive, actually. So let's change that. Let's try and run this. Thinking about what is finished is. I also need to implement a trait called debug, which will allow me to print out the value of t inside of a print line with this colon question mark mini language. Aha, unused variable is finished. Okay, that's not particularly useful. I've got a bug, and so we've got a couple of bugs actually. We cannot borrow as mutable as it is not declared as mutable. We can fix that actually by adding the mut or mute keyword. And now we're saying, this is an interesting thing. So this is another kind of subtle issue with, let's say, Rust. Actually, this is, let me just double check that I've got things right. Okay, so T is, run it one more time. What? Okay, so when you see an error like this, you're thinking, oh gosh, Rust, what are you doing? All I want is to, like, literally all I want to do is print the thing out, and you're not letting me. Why not? And Rust is saying, Tim, mate, buddy, in the context of the scope, which is essentially from line 25 onwards, you have a live mutable borrow. That means that you have provided write access to somewhere else in your program. Rust's rules prevent any other readers or writers from existing while there is a writer available. The easiest way to get around this for now is to think about borrowing as lexical scope. And so you can introduce a new scope, which should get us around that particular problem. Aha, we do. Okay, so task outcome none. Wait, that's weird. We called the function, but it did. And in fact, let's print out is maybe it wasn't finished. Now there will be people who hopefully will be screaming at the comments saying, "Tim, fix that!" And so I wonder if this makes any sense to anybody. Our future import bool does not implement format display. Okay, well that's weird because I thought it was just a bool. And the reason why I'm pointing this out, as well as making confusing error messages, is to kind of demonstrate what the async keyword is actually doing. The whole reason why we're looking at this is to talk about why async is hard. When you annotate a function with the async keyword, you're asking Rust to rewrite your code. You could think of the async keyword kind of as like a hidden macro that's very special purpose. I'm just checking to see if there are other people that are going to stamp on me for making this claim. And it looks like at this point, I haven't received anything stamping on me. Oh, except it's not, gosh, the only thing with writing it manually is that I need to get everything correct. Once upon a time, by the way, when async was being, it's output. Okay, it's not item. Once upon a time, you had to literally, in fact, you had to write worse than this impl thing. Impl in the return position didn't exist. And so you actually had to list the trait itself and say, I'm returning something which implements the future trait. And when that is ready, it will provide a bool. The work method now returns straight away, but it doesn't actually do any of this computation. Instead, what is being returned is a so-called future. And in fact, we don't even know the concrete type. All we know is that it is a type that Rust can decide, or the compiler can decide, or that implements the future trait. All we know is that when you ask the future for the value, that it will return a Boolean. But is finished is not a Boolean. So this will have multiple, so like bool is not a future. Actually, that's a different problem. Okay, so the other thing that I've done wrong, or done wrong is kind of a strange thing to say, is that now my return types are all wrong. I promised Rust, I said, hey, look, I'm returning this future thing. Can you help me out? And it said, well, dude, you are actually just returning plain old values. That's no use. I could throw on $await keyword. It will take the expression and wrap it in something that can be awaited, that implements the future trait. Now it's only allowed inside async. So we could, if we wanted to, define, like this is the value. We could return an actual future, and to do that, we would implement, like we'd have to pull in futures 0.3 or futures light, and then actually throw the thing inside. It's complicated. We're not going to bother because we have the special syntax now. We're in modern Rust, or relatively recent Rust. And so we can just return back things that look and feel like Booleans, even though the type system thinks that they're significantly different. And in fact, the implementation also thinks that they're different. So the async keyword is a shortcut for modifying the return type for a function. The .await is shorthand for taking a future and then asking for its value. So actually, me putting it in here wasn't particularly correct. But it kind of sort of is, because, and I know this is complicated, await itself is a future. It's futures all the way down. So what is finished? It's not a Boolean. It's like, but I found a future. Note that we don't have future in capital letters here. In fact, we don't actually get told what the concrete type is. All Rust tells us is that it is something which will implement the future type. But we don't see the concrete type in source code. We don't have a definition like we did with our task of the future itself. We don't. what we could do if we really felt like it, which we really don't, will be a task. We could have the thing in here, which is something else, which is a task, and we could implement future for our thing. We could do that all manually if we really wanted to, but instead we've got all these helper keywords to do that for us. So you could think of async and await as being special purpose macros for writing code that creates both types and traits that both actually they just create types. The traits are already written. They create types which are able to work with your code in a relatively straightforward way, with the very significant proviso that the error messages become significantly more opaque, because you're like, dude, compiler, here's my Boolean. It's right there on line 16. It's there on line 18. It's true or it's false. And you're telling me here down on line 27 that is finished is not a Boolean. Look at the return type. It says Boolean there. Why can't you find me? Why is that not a Boolean? And this is why people get confused, because they look at the source code and think that's the code that the computer is actually thinking about. But the compiler uses async, rewrites your function, changes the return type underneath you, and gives that to is finished. So if you are confused by async, again, this is another instance in where the different priorities of the Rust language are in conflict, and the learning process is harder. So you as the learner need to figure out. So you as the learner just need to remember that this will all come. Like, to me, I don't see this as alien anymore, which strikes me as, which is kind of bizarre when I explain it out loud, that Rust is doing all this work underneath you and your source code isn't actually the code that is compiled. But I know why they did it. And they did it because they wanted to provide, I say they, the Rust language team, really wanted to provide an experience that's as easy as possible while also being extremely high performance, that you could not write faster code yourself. Because here's the other thing, that even if you get all of the syntax right, we'll just avoid is finished. We'll just avoid defining the type. Even if you were to get all this right, our task is still going to be outcome none, because we haven't actually sent any work forward. So one of the things that we could do would be to poll. The poll method comes from the future trait. So we go back to the standard library documentation. I know this because I've been around Rust for a while, and I know that futures have a poll method, and it returns something that's even more bizarre. It returns this poll thing that has self wrapped in pin. Huh? We haven't seen that before. And we need to supply some sort of context argument, which we don't have access to. And then we get a poll thing, which probably is going to provide an output. So this is also going to, polling or calling poll is the way that you get a future to do some work. You essentially, another word you might be able to use is like step, or you could ask it to move forward in some way. And you are essentially nudging the thing forward. We need what's known as an executor. Gosh, I've just jumped around tabs. And an executor, you could think of as conceptually like this. So let mute executor is, let's just say that we had an executor. We initialize it, and then the executor, we don't have keyword arguments in Rust, but let's say that we had CX context, and then so we would have the output, and then the executor would somehow know how to get value from output. It's not even very accurate in terms of how it works, but we could think of the executor as doing something in conjunction with a future. It's essentially driving the computation. Another way to look at it, it is executing the function. Gosh. It's right there in the name executor. As long as you don't think of executor and the like killing, like the English language is very odd. Now, I need to drive us back to reality because we don't have the ability to pass keyword arguments. We don't need to, we can't, we're not really sure what the executor has. In fact, we don't even call poll ourselves. The executor does that. So wouldn't it be great if there was like a baby executor? And so this is where Tokio comes in, by the way. So here's the great reveal that we have a runtime. Gosh, that's actually subtly different to what I'm talking about. The runtime includes much more. What we really just care about is an executor that can drive computation forward through an executor. So what we want to do is, this is already too much. So we've got these nice helper macros, but it's pretty close. If we go to the implementation, let's look in the internals of what this Tokio main helper macro actually is, for two reasons. One of them is that it's exactly what we need to do outside of the macro, so what we need to do right now if we wanted to do computation. Also, there are some other projects, like most web frameworks have also taken on a convention of providing a wrapper around main to enable main to be async. And I'll get to that latter point later. So what we need to find now is main. And specifically, the only problem is that we need to find the macros. So I think this here is the macro. Now this is quite complicated because it's the actual macro. So it's talking about how to parse the source code. I kind of don't care about any of that. I just care about this build config thing. So gosh, what's that? And here is I need to go find build config. What it's trying to do is create the configuration for a Tokio executor and then implement it. There is, we'll stick with this. There is actually a simpler way forward, which avoids Tokio, but we're in Tokio land now. So let's figure this out. I feel like we're on the quest. We should finish the quest before proceeding. Build config. So this is a bunch of things that you can specify to the executor. So for example, if you wanted to, let's just do it in our code anyway. So if I was to use this I would say Tokio main, and now this becomes async. I don't need an executor because the executor new is actually what Tokio main is setting up. That's the config for the executor. So one of the parameters that I can provide would be num threads, I think, or core threads, is renamed to worker threads. Okay. So let's say that we wanted a multi-core executor. In fact, I might just ask for a single-threaded executor just for fun. And you know what I'll do? I wonder if this will work. I have an interesting thing that I can do, which is to ask the compiler to spit out the macros, like the code that will be sent to the compiler. Current thread. Current thread looks fine. Okay, we'll do that. No, wrong. Expand macros. Not run. Executor is okay. Actually, this is good because we're at a compilation error. So it's, but this is actually what I wanted to do. So ignore the stuff around how to implement debug. I kind of don't care about that. What I care about is what main looks like, because that's curious. It looks different. I'll just get rid of that. So this is the nice code that you see normally, and let's put the ugly code in, and I'll delete some lines that aren't necessary anymore. So this is the same thing as doing this. Just to clean it up ever so slightly, I'm going to call one more tool, which is Rust format, which should actually just clean this up. Here we are. Finally, here is my Tokio runtime builder, new current thread. What this does is return a, we don't need the macro. I don't know if I'm going to get rid of this print format args thing as well. Yes, and we're just going to replace it with the nice code. I say nicer code. You'll note though that the async block the async, it's not a block, it's an expression, needs a trailing semicolon, whereas I had it here on main. But so here's executor. And what we tried to do was is finished. This is the code that we're trying to replace, poll. And we somehow needed to, what did we need to do? We needed to give it a context. And we thought, oh yeah, we'll pass it in some sort of executor dot context or something. We don't know what it's supposed to be. We're crazy. We're blind here at the moment. But we just want t. In this case, it's up in line 41. But this is what we want. We want it to compute some actual value. We want it to not be none anymore. We're sick of none. We want some. In fact, we want some between 0 and 100. That's why we're here. We're here to figure out what's going on. Ignore all of this. Most of this is junk. It's telling us that it's relaxing some clippy lints because it's auto-generated code, so the user isn't going to be able to do much about it anyway. But none of that is really. Oh, actually, I do need to bring in. So we put all configuration. We enable it all. Then we build, which creates the executor. But we also need to. It returns a result. And it includes an executor inside. It probably includes a result inside it. I'm just teaching you some other crazy Rust just in case you felt like confusing your colleagues with some unconventional code. It's commonplace to call expect like you have been. However, we can also just use patterns with let. So you've probably seen if let for some, but here you go. We can actually call it on results as well. And otherwise, we can panic. And we'll just add a tier because that's the kind of feeling. I don't know, is there a better tier? Building the Tokio let's say runtime. They use the word runtime because Tokio is actually more comprehensive than just the executor. We don't care at the moment. What we're really, really interested in doing at the moment is expanding the line 49 body is all we have access to. We don't have access to T after body is wrapped up. So kind of you could think of it like we don't know anything inside there. But we do have a future. So we know that the async keyword takes an expression and converts it into something which implements future that can be awaited upon. So what happens is you call executor and then say block on. Perhaps it would be more fun and more if you just said, if they had a helper method, which was start, or start here, but they don't. In fact, instead of having a specialist method that, oh gosh, a specialist method just for initializing the very first future, that by the way is not async. So remember, now that we are not in macro land, we're not using Tokio main, we are just in a plain main function that is in synchronous mode. We need to stay in synchronous mode, so we block. This is a blocking call to body. Sorry, it is a blocking call that will not return until all of the computation inside of the body expression is finished. Maybe that makes sense, maybe it doesn't. And sadly, when I click run, it is still going to say none. T will not be done, will not be finished. The question that you have got about 7 seconds to answer, unless you push pause because you're watching the recording, is why not? We've called work. I suppose in this case, it's random. So it's 50% of the time it's still going to be some, but let's actually just change that so that I can guarantee that, okay, we'll do this to kind of avoid any confusion. Outcome is still none. So you've had more than 7 seconds. So I'm going to sort of let you in on the trick. Work returns a future, not not a value. So we need a value. So we need to await inside of our async block. Now we can, while, I wonder if I can do this actually. In fact, it's not while, it's, gosh, let's get this wrong. Let's get this run is finished, and then we'll clean up the code. If is finished, time for coffee. We're done. So it's coffee break time. So we now have working code. To go back to that original point of why is Rust async hard? It's because the compiler is writing a whole bunch of code that is not in your source code and compiling that. And it also introduces a completely new paradigm of thinking about the way that computation works. And that is, instead of it being synchronous, or at least being sort of linear with branching, that is, we follow the steps from top to bottom, you can arbitrarily be suspended. You can have other parts of your program executed, and it's actually not quite accurate. I just made a mistake. If anyone is into symmetric multiprocessing or cooperative multi-threading will understand what I mean. Like, the only thing that was hard in Rust is async code. And I don't think that's accurate, because there's actually lots of subtlety in the language. There are lots of places to get stuck. So I don't think that if you're stuck somewhere else, you should somehow feel like you're less of a Rust programmer. But async is particularly difficult because it's different. You don't actually see the code that is being compiled. You don't see the execution flow in the same way that you would read a book. It's much more like a choose your own adventure, if anyone still rolls the dice and does choose your own adventure books. And like interactive fiction, maybe, which is probably even more niche, you jump around a lot. It's kind of part of the game. And that's tricky. The other thing that makes async really hard is that most people that come to Rust to do web programming. They want to build APIs. Most web frameworks in Rust are written in async Rust. That means that async is being learned by people who are learning Rust. So they kind of have to learn like 4 things at the same time. When we run out of working memory, when we exhaust our working memory, we're less able to learn new things anyway. And so those are a whole bunch of reasons actually Rust is really hard.